this problem, I need to factor completely the expression 3a squared minus 15a minus 42. Now remember, the first thing you do on every factoring problem is look for a greatest common factor. So looking at the coefficients, I have 3, 15, and 42. Well, I know 3 divides into 3 and 15. Does 3 divide into 42? Yes. So I can definitely pull out a common factor of a 3. Do they have any variables in common? No, my constant has no variables, so the only GCF I can pull out is positive 3. Now, if I pull a 3 out of a 3a squared, what does it leave behind? It just leaves an a squared. Remember, when you factor something out, it's like dividing this term 3a squared by 3. So it's just going to leave a squared minus 3 divides into 15 5 times, so it's going to leave me minus 5a minus 3 divides into 42 14 times. So now I've factored out my greatest common factor, and now I'm going to work on factoring this trinomial. It's going to be a lot easier to factor a squared minus 5a minus 14 because the numbers are a lot smaller than in the original problem. So now how do we factor trinomials? We factor them by comparing them to ax squared plus bx plus c, where a is the coefficient of the squared term. So I'm going to work on the factored polynomial, not the original one. So what's the coefficient of the a squared term? Well, remember, we're too efficient to write it, but there's an invisible 1 in front of the a squared. So I know that a is 1. B is the coefficient of the x term, or in this case, the a term. It's going to be negative 5. And C is the constant term of negative 14. Well, we multiply A times C. So I get 1 times negative 14 is negative 14. So I'm looking for two numbers that multiply to negative 14 and add to B, which was negative 5. Hopefully these numbers come to you fairly quickly, but if they don't, I'm just going to use the systematic method of finding them. Two numbers multiply to a negative. That means they have opposite signs. And if they add to a negative, the one with the largest absolute value has to be the negative. So I'm going to have 1 times negative 14. They definitely multiply to negative 14. But what is 1 plus a negative 14? It's negative 13, not the number I'm looking for. Does 2 divide into 14? Yes, so I'm going to have 2 times negative 7. This is looking promising. 2 plus a negative 7, what does that add up to? Negative 5. That is the number I'm looking for. So as the coefficient of the squared term was a 1, these numbers are my factors. So I get, don't forget, you have to bring down the GCF, and then I'm going to factor it into two binomials, and I'm going to have a as my first term, as a times a is a squared. And then what are my two factors? I'm going to have plus 2 and minus 7. So my answer is 3 times the quantity a plus 2 times the quantity a minus 7. So I have factored my trinomial, but remember, every factoring problem you can check. How would I check this one? I'd FOIL out my two binomials, then I distribute 3 into the answer, and I should land up at my original problem.